Hi guys, welcome to my channel. Just in a quick introduction, this channel is just to provide solutions to problems that some university electrical engineering students are facing and solutions to problems that electrical engineers in the field just need a touch up on. So for the first problem we have here, we have a circuit here. So you can see we have the circuit. We have a circuit element that's unknown to us, 1, 2, and 3, that has current going through it and voltage across its terminals. We have an independent current source here, we have an independent voltage source, and we have a dependent voltage source. A dependent voltage source depends on IS, as described by 8 times IS. IS is just the current that's going through the current source. So for this circuit, we want to find the power absorbed and supplied from each of the elements here. And we want to find what I naught is. So we know that power is equal to the current times voltage. And this in units is just in watts. So for example, the power of this current source is equal to the current that goes through it, 2 amps, times the voltage. Now, since the current is going in through the negative terminal, we say that the voltage drop, or just by convention, the voltage drop will just be negative 6 volts. So we can say negative 6 volts. And this gives us negative 12 watts. Since it's a negative power, we say that the power is being supplied. Same goes for this voltage source here. Say the power of the voltage source is equal to 8 amps, and since the current is going through the negative terminals, say negative 4 volts. And this gives us negative 32 watts, which is, again, the power is being supplied. The power of the dependent voltage source is equal to the current, which is 8 amps, times the voltage across. Since it's going to the positive terminal, we say 8 IS. This gives us 11 amps times 8 times IS, which is 2 volts. Gives us times 2, 16 times 11, gives us 176 watts. But now this is a positive power. So we could say the power is being absorbed, right? So these are negative, so it's being supplied. And since this is positive, this is being absorbed. So since we did the sources, let's focus on these current elements that are unknown to us. So the power of element 1 is equal to the current going in, which is I naught, and since it's going through the positive terminal, say 6 volts. And this just gives us 6 I naught. We don't know whether this is going to be supplied or absorbed, because if it's a negative current, we would say, okay, well, this will be supplied. If it's a positive current, this will be absorbed. Power of circuit element 2 is 9 amps times negative 12 volts, since the current is going to the negative side of the terminal. So that just gives us 9 times 12, gives us negative 108 watts. Power of circuit element 3, we have 3 amps times negative 10, because it's going through the negative terminal, gives us negative 30 watts. Now, the sum of the power of the circuit is equal to 0. So we could say, okay, well, that just means the power of the current source plus the power of the voltage source plus the power of the dependent voltage source plus power of circuit element 1, 2, 3 equates to 0. So we know the power of the current source that we got was negative 12 watts plus the power of the voltage source that we got was negative 32 watts plus the power of the dependent voltage source we got was 176 watts plus power of 1 was 6 IO plus P2, which is negative 108 watts, plus P3, which is negative 30 watts, equals 0. Well, if we isolate for IO, we get 6 IO equals, get negative 12 minus 32 plus 176 minus 108 minus 30 equals negative 6. Bring it to the other side, we get 6. IO equals 1 amp. Therefore, we could say power of circuit element 1 is equal to 1 amp times 6 volts equals to 6 watts. And this will be power absorbed. So this will be power absorbed, this will be power supplied, and supplied as well. And that's it. Thank you.